This is 2-6 rational functions. Let's first define, and we'll ask the question, what is a rational function? I'm going to give you a real simple definition for what a rational function is. We're going to spend a little bit of time graphing it today. And it is simply this: a polynomial over a polynomial. If I give you a polynomial on the top and a polynomial on the bottom, that is a rational function. And that is, we're going to talk about some very important things, some characteristics, some things that I want you to find about these rational functions as we graph them. Let me first define something very quickly. My rational function will be set up like this. My top polynomial will be represented as the numerator. So let's call that capital N of x. Okay? This is my numerator. And my denominator will be capital D of x. So if I talk about the n, I'm talking about what are the characteristics of the function that's on the top. And the d is on the bottom, and so on. There are some, let's call this the list. I want to give you the list of all of the things that we're going to be talking about with the numerator and the denominator. Number one, where my top, or the numerator function, is equal to 0. So if I were to set the top equal to 0, it tells you something about the graph. Where the top is equal to 0 gives the x-intercepts, and we're going to be finding them very, very soon. That is, where does my graph cross the x-axis? I don't know. Let's take the top and set it equal to 0. Number two, where the bottom, the denominator, is equal to 0. And what does that mean to you? Okay. Okay, it's not real, right? It's not in the domain. But we can still use it to find something about this rational function. Okay? And what this is going to do, if I set the bottom equal to 0, this is going to give, let's call them the vertical asymptotes. A-S-Y-M-P-T-O-T-E-S. Have you ever heard of that word before? Okay. I'll define it verbally for you, because we're gonna know very quickly what they are. They are dotted lines on the graph that your function will approach but never ever touch. Okay? That is, don't write this down, just watch. Over here, remember our parent graph of something like y equals 1 over x, right? What I have here is, as my x numbers get very, 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 very huge, what happens to 1 over x? Doesn't that get very, very, very small? If I have 1 over a billion, that's a very tiny number. So as I get bigger and bigger and bigger and bigger with the x values, my number is getting smaller and smaller and smaller towards the x-axis, right? If my number is very, 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 very small, 1 over a very, 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 very small number is very, 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 very big. So this number is going to get closer and closer to the y-axis. Don't write this down, just watch. So as this little branch comes down, closer and closer, it approaches the x-axis but never touches it. It's called an asymptote. All right? And it is defined by a dotted line. All right, I have a vertical one and a horizontal one in that graph. And notice, this is a rational function too. 1 over x is a polynomial 1 over polynomial x, which is why I have asymptotes there. And finally, number 3 is the toughest one of all. I want to divide this up into 3 parts, A, B, and C, because there are 3 cases, A, B, and C. And I'm talking to you about the degrees. If the degree of the numerator is larger than the denominator, it's an if-then statement. You have no horizontal asymptote. And this is going to be the case sometimes. There are three possibilities. Not only do I want to tell you that this is true, I want to explain to you why it is true in a second. What's wrong? Part B. If the degree of the numerator is equal to the denominator, you have a horizontal asymptote at the leading coefficient divided by the leading coefficient. I will explain to you what it means in a second. All right? But I just want to tell you this information for now, and we'll get to it as an example. And finally, part C. This is list number 3, part C. If the degree of the numerator is less than the denominator, you have a horizontal asymptote at the line y is equal to 0. Y equal to 0 is also called the x-axis. Now, we're going to practice these. Thank you very much. We're going to practice these one at a time, and after we practice these one at a time, we're going to wrap it all up, and we're going to put them in a nice graph, which is why I gave you the graph paper today. Okay? Let me get you a piece. There's some. Let's start out by doing this. Find all asymptotes. We're not going to graph them just yet. I just want to practice by finding all the asymptotes. All right? Let me give you a function. This function is 10 over x squared minus 4. 10 over x squared minus 4. Number 1 on my list is only talking about the intercept, so I don't have to do that just yet. Okay? The directions say find all the asymptotes. Let's start off with number 2. Where the bottom, the denominator, okay, lower force, numerator function, denominator function, one over the other. Where the denominator is equal to 0 gives my vertical asymptotes. So let's set my denominator, x squared minus 4 equal to 0. That means x squared equals positive 4. And when I take the square root, x equals plus or minus 2. This, I have 2 this time, and that's okay. It will happen. You could have more than one vertical. You ever graph something on the calculator, and you have that line that goes straight up and down, right? Right? It'll graph something, and then it'll graph a line down, and then it'll graph something else on the right. That's a vertical asymptote. What? Makes you confused. You know why? Because a vertical asymptote is not part of your graph. It is a characteristic of your graph. In this case, I have 2 of them. Let's call these the VA. I got 2 of them, one at 2 and one at negative 2. Now, it is only one of these 3 cases right here. Think about the degrees. Is the degree of the top greater than the bottom? Yes or no? Question. What is the degree of the top? The degree is the highest exponent. 0. Thank you. What is the degree of the bottom? 2. The degree of the top is 0 because, technically, really, this is really like 10x to the 0 because x to the 0 is just 1 and 10 times 1 is just 10. So the degree is 0, the degree is 2. Which of these cases am I going to be looking at? Case C. It's where the degree of the top is less than the bottom. So my HA, my horizontal asymptote, since my degree of the top is less than the bottom, is at y equals 0. So I found all my asymptotes. Think about why this is true for a second. Think about why this is true for a second. As x gets very, very, very large, what is going to happen to my original function? It's going to get very, very small. That's right. Because all I have on the top is just a 10. And if I plug in 1,000,000 down here, I have 1,000,000 squared, which is 1,000,000,000,000 minus 4. So I have 10 over 999,999,999,996. And 10 over that huge number is very, very tiny. Can you see how it's getting tinier and tinier and tinier? The bottom is going to overtake the top, and I will have a number very close to 0, which is why my graph is going to approach 0 horizontally. Leading coefficient. Watch close. Let me do another one. G of x is going to be 3x cubed plus 4x minus 2 over x plus 7 and x minus 3. Now these are going to seem kind of ridiculous sometimes, and that's okay. All we have to do is just break them down one at a time. Step 1, find all asymptotes. Let's go to list number 2 and find the vertical asymptotes by setting the denominator equal to 0. What I have here is a factored function or a factored polynomial already set up for us. What are the roots of this polynomial? -7 and +3. So I have 2 vertical asymptotes, one at -7, one at +3. Okay, let's look at the degrees. Where is a horizontal? Look, these 3 cases right here are telling you where your horizontal asymptote is located. Okay? And by the way, you will only have one of these if you have one. Because in case number 1, you have no horizontal asymptote. What?
What is the -7 and 3?
What is the -7 and 3? These are VAs. These are vertical asymptotes, Walker, because that's where my bottom is equal to 0. You.
Would there be no horizontal asymptote?
Yes, why?
Because the top is 3 and the bottom is 2?
That's correct. The degree of the top is 3, and the degree of the bottom is 2, because this is x squared, and so what I will say here is no horizontal asymptote. What's up?
Now, when you graph the first one, how do you, like, I got some weird looking thing.
Can we just graph it later? I just want to get the basics of it down for right now, okay?
Because the x-intercept is asking you to find the asymptotes.
Let's look at h of x.
So you do b.
Okay?
You said x.
-6x squared over 2x squared plus 5. 2x squared plus 5. Okay, let's think about this for a second. Directions, find all asymptotes. Let's first find the VAs. Let's make this VA and HA. Vertical asymptote and horizontal asymptote. We'll see what they look like in a second. My vertical asymptote is found by step number 2, which is setting the bottom equal to 0. 2x squared plus 5 equals 0. Now watch this very closely. When I subtract 5 from both sides, I have 2x squared equals -5. And when I divide by 2 on both sides, I have x squared equals -5/2. But when I take the square root, wouldn't this be imaginary?
Yeah.
But asymptotes are real dotted lines that you are drawing on the graph, right? So since I have, like this would be x equals plus or minus I root 5/2 or something like that, my vertical asymptotes do not exist in this case. Because you can't graph an imaginary dotted line, can you?
But it's the same. So
No. We're talking about vertical for now.
I know. I was thinking.
You're going ahead of me. Mr. Williams, let's do the horizontal asymptote.
They're the same.
What can you tell me about those degrees in my function? They're equal, right? It's 2 and 2. And if the degrees are the same, is the leading coefficient over the leading coefficient. And it's going to be y equals that number. I should put this, y equals LC over LC.
Is it -6 over 2?
Okay? My leading coefficient is the number, the coefficient of the degree, which is -6 over 2, or -3. That's where my horizontal asymptote is located.
That is awesome.
Okay?
Oh.